Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good day. I bid to Dr. KARMEGAM, KARUPPIAH, and all my classmates. My name is Nuraliza binti Nazri, and before I start, I would like to apologize because I'm having a fever right now and I am having a sore throat, so my will be not very clear, but I will try my best. So for this task 5, I've been instructed to do a question 3 on leveraging 3D printing for emergency supplies. As a short introduction, leveraging 3D printing supplies is also means by innovation in disaster response and industrial safety. As we all know, disasters will disrupt supply chains and delay relief. Disasters strike fast, and logistics actually fail faster than disaster. Earthquakes, pandemic, and conflict often cripple traditional supply chains, leaving affected communities without essential medical tools, shelter, or protective equipment. And therefore, 3D printings offer localized, rapid, and customizable production. By using a 3D printing or additive manufacturing, it revolutionized the disaster response by enabling on-demand, localized production of life-saving supplies using digital blueprints and local materials. It in fact explores a real-world application and evaluates its impact. So the purpose of this presentation is to uncover how 3D printing is being deployed in real-world emergency scenarios and to evaluate its benefits, limitation, and future potential in building resilience, self-sufficient communities, and how innovations meet urgency when it matters most. So before I proceed, this is some examples on how 3D printing is being used for emergency supplies. As you can see, on the left side is for the amputees. 3D printing will provide a new hand, and second, the shelters, very inconvenient shelters to the convenient shelters, and third is the PPE, original PPE. 3D printing is being implemented to produce a fast supplies of PPE. Okay, so a background and context. Actually, a disaster exposed a weakness in global supply chains. Relief efforts are slowed by delays, shortage, and logistic constraints. Natural disasters, pandemic, and conflict expose weakness in logistics, disrupt global supply chains, in delaying critical aid like medical tools and shelters. Therefore, a shift is needed. What shift is a shift with agile and localized solution. Shift from centralized aid delivery to on-site production. As we all know, traditional relief methods will face constraints during emergencies. Therefore, centralized production and transportation are often too slow or inaccessible during crises. Emergency response require adaptable, on-demand production that meets urgent, site-specific needs. For that, we should enter 3D printing as a game changer. Sorry. So, producing supplies directly at the disaster site. 3D will produce a supply directly at the disaster site, quickly, affordably, and with minimal infrastructure. 3D printing also fits the needs of emergency relief by providing a speed, flexibility, and customization. How 3D printing being implemented? On technology mechanism aspect, it's actually a from concept to object in hours, not even a days or weeks. 3D printing is additive manufacturing. It's built object layer by layer from digital blueprints, and there is no need for molds or complex machinery. And this is how 3D printings work in emergency. First is by providing, we provide a digital design files, CAD files being created or downloaded. Open sources or custom CAD files will guide the printers, and it can be shared globally and produced locally. Second is we have a diverse material input, starting from plastic, resin, metal, or local material like soil. We can use plastic, resin, concrete, and even biodegradable or recycled materials, which can be chosen based on need and availability. Third is layer by layer printing. Object is built additively in real time within the community. 3D printing is deployable anywhere. mobile and desktop 3D printers. 3D printers can ranging from compact unit for medical parts to a large-scale printers for shelters, and it can be deployed in the field or nearby hubs. And 3D printing is actually a local and global integration. It's combined a global expertise with local manufacturing, which can bridging a distance and reducing the delays. So there's actually a variety of benefits by using these 3D printings. First, of course, is a rapid response, quick production of essential items. 3D printers reduce waiting times during critical phases. Second is localized manufacturing. 3D printings enables on-site or nearby production, and it's minimized dependency on long supply chains. Besides customization and precision, 3D printings create a tailored solution. It is perfect for individual medical needs or site-specific designs, and it's a solution for local needs. Fourth is cost-effective. As we know, 3D printing will save on transport and warehousing costs. It reduces logistics, storage, and material waste, and is ideal for resources-limited setting. Fifth is sustainable solution. By using a 3D printing, it uses eco-friendly or recycled materials. It lowers environmental impact in recovery phase soon. And 3D printing also is a community, providing a community empowerment by involving local makers, and it fosters ownership, skill building, and resilience within communities. And of course, with all the benefits, it also have a challenge. 3D printings actually is having a challenge in materials limitation because not all essential items can be printed due to compatibility issues with available materials. Second is a technical constraint. Printer may fail in harsh environment. Dust, heat, or unstable power supply can affect the performance, and slow production for large items. Time consuming when printing large or complex objects like shelters or machinery parts, and skill gaps. Of course, 3D printing will having a challenge in lack of trained personnel in disaster zones. It limits deployment and troubleshooting capabilities. Besides its infrastructure dependency, 3D printings need a stable electricity, digital design files, and sometimes internet access for updates or collaboration, and also regulatory and safety concern. Using 3D printings usually provide unclear standards with its quality, especially for medical or structural applications. Moving to the next slides. This is a sum of the critical consideration for implementation. First is 3D printings need to be infrastructure readiness, where we should invest in mobile printing labs, stable power access. Second is cross-sector collaboration. It should be considered because a strong partnership between government, academia, and industry are vital for the success of this 3D printing. Third is training and education. Consideration to incorporate 3D printing into vocational and higher education to build a skilled workforce. Fourth is mobile lab deployment. In disaster zone, 3D printing need to be equipped with portable 3D printings for rapid and on-site production. Fourth is policy regulation. We should develop standards to ensure a safety, reliability, and ethical use of 3D printed tools. Six is community involvement. We should consider and to empower a local makers and production, and also a volunteer for grassroots innovation and quick response. Seven is sustainable funding. We should ensure a long-term investment in infrastructure, research and development, and also a technology maintenance in order for this 3D printing to be implemented successfully. So for the case study, I have 5 case study, but in this presentation, I only show 3 case study. First case study is in Haiti. During a post-2010 earthquake response, we can see that community foundation able to deliver hope through technology of this 3D printing by providing a custom prosthetics as in the picture show, which is produce affordable personalized limb using open source design, and it's encourage a localized production where it's empowered a local production to fabricate and fit device, and it's of course a life-changing impact when it's restored independence and dignity for amputees within community. Second case study is, I'm sorry, the title is a bit lower. Case study 3 is Jordan, in Jordan, where the refugee shelter solution. In these cases, the urgent need for durable, cost-effective, and scalable shelter to address the Syrian refugee housing crisis, and this 3D printing using analytical hierarchy process AHP to assess optimal printing method to evaluate the concrete 3D printing. And as you can see in the image, this refugee housings is actually cost effective and durable, and where suitable materials and process are being used for harsh camp conditions. And of course, it showcases innovation in refugee infrastructure, where a blueprint for future humanitarian shelters is being implemented. So case study 5 is in Malaysia itself. During a pandemic of COVID-19, we can see a grassroots action step in when the supply chain failed, and this grassroots action is driven by ordinary citizen rather than by a central authority or organization. So using a 3D printing, a community mobile and produce and also distribute 1,000 of face shield nationwide in order to support this PPE shortage, and it shows a community-led decentralized production, which show the power of local innovation in crisis response. Fourth is a model for national resilience, because it during this case of COVID-19, it show we should strengthen healthcare readiness and a public trust. This is some comparative of analysis of my case studies that I found in Haiti, Nepal, Jordan, Italy, and Malaysia. Of course, a 3D printings provide a different focus, and it came with benefits or different impacts to within the communities, within the different communities. It's also helped in providing prosthetic 3D limbs in Haiti, medical tools in Nepal, refugee shelters in Jordan, eco housings in Italy, and also PPE in Malaysia during the COVID-19 crisis. And as a conclusion, a 3D printing is actually a game changer for emergency response. It's of course a rapid, adaptive, localized. It delivers critical supplies when and where they are needed the most. And with the strong policy, education and innovation, Malaysia can lead in this domain, because Malaysia has the tools to lead. And of course, it's built future-ready communities by empower people, strengthen system, respond smarter, recover faster. And this is the reference, some of the references that I use, and the rest of reference I've put in my essay. I'm sorry, and I think that's all for me. Thank you so much for listening.